So this is a quotient, right? It is really hard to see it immediately. Let us try to make it simpler. So can we separate it into sums of small parts? The numerator is a sum of three terms, right? They're all divided by square root of t. It means that g of t could be written as 1 over square root of t plus, what is it next? Yes. N. Very good. So t is t to the minus, t to the 1/2, right? T is t to the 1. This is another way to write this. Okay? Just power rules. So now the power rules tell us, okay, the division of two things with the same base, right? Base t, which give us, what is it here? When we, very good, t to the negative 1/2, right? We bring the term in the denominator to the numerator. We need to change the power. Here, the power of this is 1/2, right? We bring it to the numerator. It will be negative 1/2 here. And here, it will be t to the 1, right? Multiply with, we can rewrite it, t to the 1/2, and it means that it is the difference of the power 1 minus 1/2, right? And the last terms, it will be t to the what? Is it here? Yes, 3/2, 3 over 2, or 2 minus 1/2. Let us do it slowly this way. This is power rule, right? No. So are we all good here? Then let us compute the orders from here, which give us t to the negative 1/2 plus t to the 1/2, right? And here is t to the, what is it? Yes, 3/2. Very good. So, do you have any question up to this point? So, is it clear? Gary, can you see it? Is it clear? So now, remember the formula. X to the n derivative give us n x to the n minus 1, right? Therefore, if we have t here, then it should be the antiderivative of this is t to the this power, negative 1/2, but then it has 1 degree higher, right? Plus 1. in order to find the antiderivative of this. It would be this power plus 1, right? The difference of these two power is 1, okay? So, but we should divide it by this number over -1/2 plus 1. Okay, that is the first term. Or before doing that, let us write it this way. If here, let us write x to the n plus 1. Then here, it will be n plus 1 x to the n, right? From the derivative. Then if we divided both sides by n plus 1, the left-hand side becomes x to the n plus 1 divided by 1 over n plus 1 will be equal to x to the n. From this formula, right? It means that if we are given the right-hand side, we will be able to find the antiderivative of this. It will be the base raised to the order of n plus 1 and then divided by this constant. The same story applies here. Do you all see it? So t to the power of this plus 1 and multiplied by 1 divided by this power, okay? The second term, can you tell me what it is? T to the, very good, plus 1. Perfect, Matthew. It is 1/2 plus 1, right? Do you all agree with this? So do you have any question up to this point? We're good, right? Very well. Then the last terms. Here is t to the 3 over 2. Then antiderivative of this, it will be 3 over 2. Then we need to add 1 here. Then the same story, the parameter here will be 1 divided by the power of this. It will be 3 over 2 plus 1. Okay? So, then let us simplify the parameters here. Okay? Here is 1 divided by 1/2, right? And here it will be t to the 1/2. Okay? This guy, it will be 1 divided by what is it here in the denominator? Yes, 3 over 2, 3/2 here. Very good. And t to the 3/2. Very good. The same story here. It will be 1 over 5/2. Very good. Here, So now observe again. See that the denominator and the power, they are related to each other here, right? They should be the same. Okay? So that when we take derivative, they will cancel each other. Now, it is the division of a whole number. And this number is divided by a fraction. So we can change it from division to multiplication by flipping the denominator, which will be reciprocal of 1/2. It will be 2 over 1 or 2. Very good. T over 1/2. And the same story here. What is it? Yes. Oh, 2. Yeah, 2/3. T over 3 over 2 here. And yes. Very well. Then we found it, right? 2 times 1 would be 2. T to the 1/2, or we can write it square root of t, 2 over 3, t cubed square root, plus 2 over 5 here, t to the 5th square root. So, is it clear? Do you have any question about this? Very good. So now let us move on to the notes I uploaded on Moodles. Here is the table. Can you see it clearly? Here is a table of antiderivative and some particular antiderivative of some functions. So if C is a constant and F and G are functions, capital F is antiderivative of small f here. Capital G is antiderivative of small g. Then C times F will be C times capital F, the antiderivative. Plus and minus will be the same. The second formula here, x to the n, it will be x to the n plus 1, the antiderivative. We raise the power up one more order, right? But then divided by the same number. Okay? Remember, derivative of natural log of x give us 1 over x, right? Therefore, antiderivative of this will be natural log of absolute value of x. Be careful with this. It is a absolute value. The second one, the next one, e to the x derivative will give us e to the x. So therefore, antiderivative of this will be the same value, right? But be careful with the next terms here. So from the derivative formula, you can write it down and see, okay, antiderivative of b to the x will be b to the x divided by natural log of b. Okay? Memorize these, do many times, you will get used to it. Or you can prove it again as we did in the class. Derivative of sine give us cosine. Therefore, antiderivative of cosine should be sine here. Similar story. Derivative of cosine gives us negative of sine. Therefore, antiderivative of sine should be negative cosine. Similar story, derivative of tan gives us secant square. Therefore, antiderivative of secant square should be tan. The similar story for these functions. Okay. Now, let us play with some more examples. If we're given the function f here, then antiderivative of x should be antiderivative of two of these guys, right? The first terms, what is antiderivative of 2e to the x? Yes, very good. 2e to the x. If you're not sure, compute the derivative of this guy. You'll see that it will be exactly e to the x. That is the way to check it. Okay. The second term. Oops, sorry. The second term, the negative sign, let us rewrite it. Negative sign. And the constant does not affect to this. Let us rewrite it, right? Then what we care is x antiderivative of x to the minus 1. So antiderivative of x to the minus 1, it will be x raised to the power of negative 1, and we add 1 here, right, in the power. What is it? Wow, be careful. If we do it here, then it will be 1 divided by 0, right? Which does not make sense. So be careful with this. So this is the typical way to do it, but it is not applying when n is negative 1. So that is why we have this notice here. N should not be negative 1, right? So be careful with this. When n is equal to 1, it is actually 1 over x right here, right? So this is the formula we should use in this case. So therefore, this is not a good way to compute it. So we should use the natural log formula. And what is it? Very good. Ln absolute value of x. And here, this guy, look back at the table. Which formula should we use? Tangent x, right? So therefore, it should be right. So are we done? Yeah, listening. Very good. We're not done yet because this is not the most general antiderivative. The most general antiderivative, yes, we must add c, where c is a constant. And that's it. Okay. Do you have any question? Very good. Then the next one. Okay, it is square root of 2x here. It is interesting. So, okay, what should we do now? This is a formula. Let me remind you. U to the n derivative. It is n u to the n minus 1. U prime here. This, we can write it as 2x to the 1/2, right? So imagine if this guy is u, then the same story is similar to x. Then we could write it as 2x to the 1/2 plus 1, right? We increase the power 1 unit here. And then divided by this guy, what else do we need to do? Look at this. If u is 2x, therefore u prime will be 2, right? U prime is 2. And in this case, we are given u n to the minus 1, right? It means that in order to find the antiderivative, we need to do this and divide it by a constant here and divided by the u prime, which means 1 divided by 2. It's a little hard to see, but do you all see it? Why we divided by 2? This is the reason. Because u prime is 2. If u is 2x. Okay? Or you can double check it by doing this. Take the derivative of this guy, and you will see that it will not give you square root of 2x. Okay? Then you need to weight it by 1/2. What do you think about it? Are we good? Write it down, do it more, and we do. We learn from mistake. Just do it more, you see it better. So, therefore, let us simplify it. And remember, we should add a constant c separated. It's a little messy here. Then we simplify it. This here, it will be a 3 over 2. Flip it, it will be 2 over 3. And here it becomes 2x to the 3 over 2, right? And multiply with 1/2 plus c. 2 cancel with 2, which give us 1/3. 2x cubed and square root plus c. Okay. If you're not sure, we can take the derivative of this guy. Double check it, right? If it gives us square root of 2x, then we're good. What? Okay? For these kinds of problems, the more I explain, the more you will be confused. Just write it down and do it. And there are some more problems here. You go home and do the number C, number D, and number E. Let us do it here, the number F. Okay? Again, this is a quotient. It is really hard to find the antiderivative of this guy. Do you have any idea to make it simpler? Louder? Quotient rule? Yeah. Factor it out. Simplify it. Very good. Yeah. Let us try. Very good. We can see that f of x here in the denominator is x squared plus 1, right? If in the numerator, we can write it in this way. And when we separate them, we can simplify it, this guy with a denominator. Okay? Do you see it? The trick here? Because here it has x squared. If we can separate this into, here the parameter is 2x squared. In the denominator is x squared plus 1. But in the numerator, this is, if we distribute it, it will be 2x squared plus 2, which somehow 2 more units compared to the previous one here. Therefore, we need to subtract with right, to even it. Do you all see it? Or let me write it this way. If I write 2x squared here plus 2 plus 3 divided by x squared plus 1. Okay. If I separate the number 2, 5 here, this way, then 2 is the common factor. So we can factor 2 out, right? It will be this guy plus 3. Do you agree? Then in the numerator, it is a sum of 2 terms. This term plus 3. So we can separate it into 2 multiply x squared plus 1 divided by x squared plus 1 plus 3 divided by x squared plus 1. Is that okay? If we do this, the first quotient becomes what is it? Right? The denominator, we can write it 1 times this guy, and they're all product in multiplication and division. So we can simplify this and this. They cancel each other. So the first terms becomes 2, yes. Here, the constant 3, we can write it this way. 3 multiplied with 1 divided by x squared plus 1. You agree? Then now, 2, which is a constant, so we can find the antiderivative easily. This guy is 1 over x squared plus 1. So here is the formula, right? The antiderivative of 1 over x squared plus 1 should be the inverse of tangent. Therefore, here we can conclude that antiderivative of this guy, it will be 2 times x plus 3 times tangent x. It's the one here. And what is it? What else? A constant. Okay? This is one way to do it. And sometimes we may question why we know to separate the numerator into these 2 terms. If you don't want to do it, another way to do it is to do the long division, right? It's a little harder. Oops. Long division, if we want to divide 2x squared plus 5, it is divided by x squared plus 1, right? So 2x squared, the highest degree here, divided by the highest degree here, give us, what is it? 2, yes. Then we FOIL it here, give us 2x squared and yes. Then we subtract, right? 2x squared subtract 2x squared give us 0. And 5 subtract 2 give us 3. And we see that 3 is a remainder. Therefore, 2x squared plus 5 divided by x squared plus 1, it will be 2 plus 3 divided by x squared plus 1, right? This is another way to find this long division, okay? Either way is fine, whichever way is easier for you. This way or separation of variable. Okay. Then another types of problems in this section is the rectilinear motion. If we are given the position equation of a particle, then the first derivative of this gives us the velocity field, right? V. And the derivative of the velocity gives us the acceleration field, A. So now, if we are given the acceleration field, can we find the velocity field and the position field? Okay. So let us take a look at the example here. We are given that the acceleration field is given by this formula. The initial velocity is v at time 0 would be -6, and the displacement field at t is equal to 0 is 9 centimeter. Can we find the position function, right? So we know that the acceleration is the first derivative of the velocity field. It means that we can find the velocity field by taking the antiderivative of v, of a, which will give us v, right? It means we need to find the antiderivative of 60 plus 4. So, therefore, v of t would be, what is it here? Six times t squared, right? One degree higher than t here. But then remember to divide it by the power here, right? Divided by 2. Okay? And antiderivative of 4 should be? What is it? Yeah, in this case, t. T is the variable. Very good. And the most general antiderivative of this, we should add a constant c, right? Okay? So we found the velocity of this particle, which now we can simplify it. It would be v of t. 6 divided by 2 give us? Yes, 3t squared plus 4t plus c. Okay. Furthermore, we are given that at the initial time, v of 0, it will be -6, right? So v of 0, it means that we evaluate the value of v when t is equal to 0 into this function. But we know that v of 0, it will be c, right? From the formula we found it here. V of 0 will be c. And we're given that v of 0 is also -6. Therefore, c should be, yes, -6. If c is -6, then therefore v of t will be 3t squared plus 4t minus 6. So, are we good? Now, we found v, the velocity field. Can we find the position field? Displacement field, yes. The same story. We do the antiderivative of this one more time. So, antiderivative of v gives us s of t. So, it will be antiderivative of this guy, which is 3 times t to the what? Yes, to the 3. It is 1 degree higher than this, okay? But then remember to divide it by this power, right? 3. And this number, it will be 4 times t squared and divided by 2, right? And the number -6, antiderivative of this give us, yes, 6t here. But then we need to add plus a constant, yes. And because we use the letter C already, let us call it, the constant here is D, right? Where D is a constant. Again, the initial position S of 0 is 9. And from this formula, S of 0 will be 3 and 3 cancel. It would be 0 cubed plus, or let us simplify it here first. It is t cubed plus 2t squared minus 6t plus d, right? So at the time 0, it would be 0 cubed plus 2 times 0 squared minus 6 times 0 plus d, and which mean it would be d, right? S of 0 would be d, and we're given that S of 0 is 9, therefore d should be, yes, d should be 9. If d is 9, then we have S of t will be, substitute back here, t cubed plus 2t squared minus 6t plus 9, right? This is the position vector of this problem. So finally, we found this, and the velocity is here. So, thank you very much, and class dismissed today. Oh, by the way, I am reviewing the test 3 right after class now from 2:30 when I go back to my office. You're welcome to come and ask questions if you have. And tomorrow we'll have office hour from 10 to 12. Okay. So now to about 3:30 or something. You have a good one.